Hey there. So this is part two of our twoSum solution. It's a coding kata. It's the twoSum problem is we get it from the LeetCode platform, and the LeetCode platform contains all these sort of problems that are often given to people during interviews. This is an easy one, and we're going to use our nano-cycle to solve it. And we don't really need to use the nano-cycle to solve it, but the idea is to practice using that cycle and practice using our IDE so that we can eventually apply those same methods on more complicated problems. And if you remember, this problem is we have an array containing numbers, and what we're looking for is, given some number, we look for two elements in the array that when added together will give that number. For example, if the given number is 7 and we can find the two elements 2 and 5 in the array, then what we're going to return is the positions of those two numbers in our array as a result. So if you remember from part one, what we did is we assumed one of those two numbers is always in the 0th location. So you see this in our solution. Okay, the twoSum solution contains 0. The twoSum solution contains 0. The first one is when there's no solutions. And if you also look here, our IDE is even telling us that our twoSum solution is always returning 0 for that first location. Our problem now, what we're going to do is the elements can be in any location, and we're going to continue solving the problem that way. So what we do is we add a new test case. There it is, and we'll put this number somewhere else, right here. Okay, and so now this element should be 1. You see this is turned green now. So that's because this number is actually a variable, not a constant anymore. And we want to solve that. But first, before we solve it, we make sure we have a failing test case. And bang, we do have a failing test case. Oh, actually, just accidentally hit something there. Okay, we have a failing test case. And so what we want to do is now make this one solved. And actually, what we're going to do is this algorithm worked for when the solution was in the 0th location. So let's just be dumb about it and use exactly almost an identical algorithm to solve it for when it's in the next location. So first thing we're going to do before we copy it is we're going to introduce a variable. We're going to replace the 0 with a variable. Okay, we'll move it outside the loop because this variable is not changing with inside the loop. And now we're going to just copy this guy like this. Okay, and now the interesting thing here is we're going to start this guy searching at 2, and we're going to make the I equal to 1 now. So if we start searching at 2, actually it's really, if you look at this, it's actually I plus 1. It's 0 in this case, and it's I plus 2 here. What we're doing is we're searching our array, and we're taking the ith element and then searching forward from it for any matches. So actually, if we did this correct, this might already solve our problem. No, we didn't do it correctly. What did I do wrong? I equals 1, I equals 1. Oh, it's I equals 1. Sorry, that's what I did wrong. It's supposed to be I equals 1 in both cases. These loops are supposed to be identical loops, and I made that mistake. Okay, so there we go. Not perfect. It's the identical loop. Okay, so there I made the mistake. So our test pass. Okay, and we're trying to not use our mouse too much. So here's our test pass, but it looks pretty ugly, doesn't it? Look, this is just duplicated code here. So what we want to do is there's an I. It's going to start at 0 because we see this is the first value of that 0, and it's going to go to the end of our array, Okay, exactly. It's going to go to the end of the array. Actually, it turns out it only needs to go to the second last one, because if we get to the end, then there's no other guy to search for. And then we're going to take this loop here, and we're going to move it up. Like that. And now, this should just be a refactoring. And if we did the refactoring correct, our test should still work. And it did. Our test worked. So actually, this is a general solution now. And if let's make another test case and just move things around a little bit. And we'll add the number 5 here. We'll look for the number 6. And then the solution should be position 1, 2, and 3. Okay, so we have a general solution now. Now, I won't solve more of it here, but what I will say is it's not a good solution, because this is an n squared, and it turns out essentially we're looking for the same number in this loop all the time. We're looking, and to make that a little more clear, that we're searching for a number and we're doing a linear search. Actually, the number we're looking for is, we want this, because this part is unchanging, isn't it, during the loop, and we'll call that the complement. And since it's unchanging during the I loop, we can move it out here. And if you see it, what we're really doing is looking for this number in the rest of the array. And I won't solve it right now, but there's a better way for looking for a number than doing a linear search. If we know the number we're looking for, we can put it into some sort of data structure like a hash, and then we'll be able to find it. And this will go from an n squared to sort of a constant, an n sort of a search. But I won't do that right now, but you can kind of see how that was easy. Okay, thanks.